Hi everyone! Today's lesson is going to be on chemical reactions and enzymes. Our goal for today's lesson is to describe what chemical reactions are and how activation energy affects them. Here's some vocabulary to keep an eye out for. Chemical reaction, reactant, product, activation energy, catalyst, and enzyme. So let's think about this. Living things are made up of chemical compounds, but chemistry isn't just what life is made of. Chemistry is also what life does. Everything that happens in an organism, its growth, its interaction with the environment, its reproduction, and even its movement is based on chemical reactions. So let's talk about what those are. Everything that happens in an organism is based on chemical reactions. A chemical reaction is a process that changes one set of chemicals into another set of chemicals. Here's a common chemical reaction in nature called photosynthesis. In this equation, the reactants are on the left side of the arrow. They're kind of like the ingredients that go into the reaction. In this case, our reactants are carbon dioxide from the atmosphere and water. On the right side of the arrow, we have the products. These are the elements or compounds that are produced by this chemical reaction. In this case, we've got organic matter, sugar, and oxygen. Here's another example of a chemical reaction that allows your body to get rid of carbon dioxide. So your body tissues are putting carbon dioxide into the bloodstream. And in the bloodstream, the carbon dioxide reacts with water to make carbonic acid, which is easily soluble. Then, once that gets to your lungs, the reverse reaction happens, and it splits again into carbon dioxide to leave your lungs and water again. An important thing to understand is that some chemical reactions release energy and others absorb energy. Energy releasing reactions usually release energy in the form of sound or light or heat, and what's happening is the breaking of those bonds is releasing energy to be put into another molecule somewhere else. Energy absorbing reactions are the opposite. An example of this is cooking an egg. If you break an egg into a pan, nothing is really going to happen until you add some energy to it. In this case, you're adding energy in the form of heat. Regardless of whether a reaction absorbs energy or releases energy, it still needs a little bit of energy to get the reaction going. So let's take a look at this. Here's an example of an energy releasing action. You start with this amount of energy right here in your reactants, and your end result is much lower. That's because some energy has been released. However, you do have to put a little bit of energy in to that reaction to get it going. That's called the activation energy. Okay, so you start at a certain level, you end at a lower level because energy's been released, but you have to put a little bit of energy in to begin with. Here's the same kind of graph in an energy absorbing reaction. You start at a low level of energy and you end at a higher level of energy, but you have to go just above that amount of energy to get that reaction going. So that's the activation energy. So let's talk about how this applies to life. Well, some chemical reactions that make life possible are too slow, or they have really high activation energies that are too high to make them practical for living tissue. So this is where enzymes come in handy. Living things use enzymes to help speed up reactions that would normally take too long to happen on their own. In this graph, the activation energy of the reaction without an enzyme is shown in blue. Okay, it's got a pretty high activation energy, which means you have to put a lot of energy in to make it happen. And sometimes that's just not easy to do in living things. Okay, so your body uses something called a catalyst. A catalyst is a general word for a substance that speeds up the rate of a chemical reaction, okay, whether or not it happens in living tissue. The catalysts that happen in living tissue are proteins called enzymes. So enzymes are a type of catalyst. And how enzymes work is they actually lower the activation energy required to get that reaction happening. So now with the enzymes shown in red, the activation energy is much lower. So it's not going to take quite as much energy to make that reaction happen, which allows that reaction to happen much quicker for living things. In our next lesson, we're going to talk a little bit more about enzymes and how they work. But for now, let's review our goal for today's lesson. By now, you should be able to describe what chemical reactions are and how activation energy affects them.